Today, we're diving into a pretty profound and honestly kind of unsettling idea in neuroscience. It's this concept of the ghost in our genes. And it forces us to ask,
What if the reason some people can't feel joy anymore, or don't respond to music, or even react to certain substances, isn't because there's some chemical left over in their brain? What if it's because the actual genetic instructions to feel those things have been switched off? Not gone forever, just silenced.
you know, for a long time, we thought we had the story straight on how certain psychiatric drugs work. But now, a new, much more permanent idea is starting to surface, and it challenges pretty much everything we thought we knew. So, the old explanation was pretty simple, right? A drug goes in, it temporarily blocks a receptor, and when the drug is gone, the brain just bounces back. But this new hypothesis, it's way more radical. It's suggesting these drugs aren't just putting a temporary block on something. They might actually be rewriting the brain's fundamental operating code for life.
And look, this isn't just some abstract theory. It's coming from real people's experiences that just don't fit the old model. Take the case of a man named Gabriel Philippi. He was on the antipsychotic Zyprexa for just 1 month. After that, his ability to respond to things like LSD or cannabis just vanished. Not weakened, gone. And it never came back. That just doesn't sound like a temporary block, does it? It points to something much, much deeper.
So, okay, if it's not just a temporary block, what in the world is going on? Well, the answer might be hiding in this really fascinating field of science that acts like a ghost in our own genetic code, epigenetics.
Here's probably the easiest way to think about it. Your DNA, that's the hardware in your computer. It has all the potential programs you could ever possibly run. Epigenetics, on the other hand, is the software. It's a whole system of chemical tags that tells your genes when to turn on and when to turn off. It doesn't change your actual DNA, but it has almost complete control over what your DNA does.
So how does this genetic software actually pull this off? It has two main tricks up its sleeve. The first one is called DNA methylation. This is where a chemical tag literally clamps onto a gene, and that physically blocks it from being read. The second is histone modification. You can think of this like the software telling the proteins that package your DNA to just wrap everything up super tight so a specific gene gets buried and becomes totally inaccessible. Either way, the result is the same. That gene is silenced.
All right, so let's connect this all back to the central mystery here. Could these medications be using this epigenetic system to actually rewrite the brain's code?
This is the million-dollar question, isn't it? Could antipsychotic drugs be the very thing that triggers this epigenetic software to go in and permanently silence some of the most important genes in our brain?
And the initial answer we're getting from animal studies is a pretty stark and, frankly, pretty unsettling yes. The evidence is definitely pointing in that direction.
For instance, in one study, scientists gave rats the antipsychotic haloperidol, and what they found was increased methylation. Remember, that's the off switch on the DRD2 gene. This is the gene that builds our dopamine receptors, which are absolutely crucial for things like motivation and feeling pleasure. They saw similar silencing on genes for serotonin and opioid receptors too, the ones that handle mood and reward. And here's the real kicker. These changes to the genes were still there long after the drug was completely out of the rat systems.
You know, one researcher put it in a way that just clicks. They said it's like a software update that disables a core app on your phone, but then it won't let you reinstall it. The instructions to build these vital brain receptors aren't just being blocked. The brain may have actually lost the ability to build them at all.
And when you think about it like that, it completely reframes what people who experience this are going through. It suggests their struggle isn't about some failure of willpower. It's a fundamental biological change. So this theory suggests that if someone literally can't feel pleasure or connect with a piece of music anymore, it's not because they aren't trying hard enough. It might be because the genetic instructions for how to have that experience have been, well, erased. It's a biological issue, dictated by a change in the software.
Okay, I know. This all sounds incredibly grim. It feels a bit hopeless. But what if a code that can be written can also be unlocked? What if the very same science that's revealing the problem could also hold the key to the solution?
And this is where the story takes a turn. This is the good news.
Unlike your DNA hardware, which is pretty much set in stone, these epigenetic changes, the software, are potentially reversible. Those chemical tags can, in theory, be taken off.
And researchers are already exploring a few really cool ways to maybe pull this off. There are drugs called HDSC inhibitors, which are designed to help that tightly wound DNA loosen up and unlock the silenced genes. We're also learning that things like lifestyle changes and even some therapies might help the body repair these epigenetic marks on its own. And way down the line, super advanced tools like CRISPR could one day let us target one specific gene and just flip its switch from off right back to on.
As one molecular biologist, Dr. Arjun Patel, explains it, the fact that this silencing sticks around is the problem, but it's also the target. The goal isn't just to treat symptoms anymore, it's to find a way to reverse the change at the most fundamental level, the genetic level.
I mean, can you imagine if we could really learn how to turn these genes back on? It would be so much more than just recovery. It would be giving a person back their biological, built-in ability to experience the world. That's not just recovery, that's liberation.
So this whole emerging field of science is just opening up a new frontier. And it leaves us with a really powerful question. If our brain's own code can be silenced, what is it going to take scientifically, ethically, and just as human beings to help it find its voice and learn to speak again?